There are 92 protons and 143 neutrons in a uranium atom. And in a nuclear energy reactor, what happens is that a tiny neutron is thrown at a uranium atom, and this uranium-235 atom, it absorbs a neutron. And this makes the nucleus extremely unstable, and it splits into two smaller nuclei. This splitting releases a huge amount of energy, and we use this energy to heat water, which is turned into steam, which then spins a turbine. And when the turbine spins, we get electricity. Almost all countries use this process, which is done in something called a light water reactor. But you know what? Even with uranium, there was one big problem. Homi Bhabha understood that even for uranium reactors, we had to import uranium from other countries because India only had world's 1 to 2% of uranium, and we needed to use something that was readily available in India itself. So you know what? Homi Bhabha realized that a precious fuel source was lying in our beaches, in our sands, and this magic material is called thorium. For those who don't know, thorium is again another element which is silvery, slightly radioactive, and which is even more cleaner and more energy efficient than uranium. And the best part is that India has one of the world's largest reserves of thorium. In fact, we have 25% of the entire world's thorium. Look at this chart. Millions of tons of monazite sand is even today found in the coastal regions of Odisha, Andhra, Tamil Nadu, Kerala and Jharkhand. So Homi Bhabha knew that thorium was a life-changing resource for India. But the problem was that no other country had used thorium before, so there was no blueprint on how to use thorium to produce nuclear energy. So here's where Homi Bhabha came up with a unique 3-step nuclear program as a way to develop nuclear energy by using this thorium. Now again, this is a little technical, but then stay with me. In this 3-step process, stage number 1 was to use uranium in reactors to produce electricity and generate plutonium as a byproduct. In stage 2, this plutonium is used to generate a lot of electricity and produce more plutonium from uranium. Secondly, they start producing uranium-233 from thorium itself. And then in stage 3, thorium is used along with uranium-233 produced in stage 2 to produce even more energy. And for all these 3 stages, we needed different types of reactors. And more importantly, back then, all these stages required extensive research and development. And if completed, it would have turned India into an energy superpower. And Homi Bhabha achieved such quick success that in 1956, India got its first light water reactor called Apsara, and we built 2 more by 1961.